Alright, so here in this particular center of mass video, we have 2 point masses of 2 kilogram and 8 kilograms that are a distance of 10 meters apart on a horizontal line here. Alright, and this is find the center of mass relative to M1. So here in this particular diagram, M1 being on the left, M2 being on the right, and they are 10 meters apart. Alright, so let's go ahead and do this one. The generic center of mass function is this right here. It essentially tells you add up all the masses relative to where they're placed and divided by the sum of all the masses. All right, so in this particular diagram, reference points are not given. So when reference points are not given, I encourage you to just go with the easy stuff. So if you can keep up here. All right, so here we can expand this particular center of mass function to M1 times where it is located x1 plus M2 where M2 is located plus dot dot dot. In this case, there are only two masses, so we can just stop at M1 and M2. And then the sum of all the masses here in the denominator is M1 plus M2 plus dot dot dot. So this particular function can be used for any given amount of particles. But for this particular problem, we only have two, so we'll just stop at M1 and M2. All right. So here, because a reference point is not given to you, I'm just going to go ahead and call M1 being at the origin. All right. So if one is not dictated for you, you can just make that choice yourself. So here, I'm just going to put M1 at the origin or at x is equal to 0. Therefore, if x is 0 here, where M2 is located, would have to be 10 because the problem states that they are 10 meters apart. All right, so once you have these reference points, you can go ahead and just crack out the problem. Here, M1 is 2 kilogram, X1 is going to be at 0 because I have chosen to put M1 on 0. And then plus 8, the second mass here is 8 kilogram on the right side of the diagram. And this will be 10 meters. And then that's in the numerator. And then in the denominator, you would simply add the number of masses together. Here we have 2. We have 2 kilogram plus 8 kilograms. So if we simplify this, 2 times 0 is just 0. And then 8 times 10 is 80. So the numerator will simplify down to 80. The denominator, if you add 2 plus 8, that would be 10. The units here, kilogram, will cancel out. That would just leave us with the units of meters, which makes sense because we're trying to find the center of mass of something. Here would be units of meters. All right. Other than that, 80 divided by 10 would just be 8 meters. So the center of mass for this particular system relative to M1, based on my reference point here, would be 8 meters to the right of M1. So visually, this is where it's measured to and from. It's going to be measured from M1 because it said so in the problem, and then it's going to go all the way to 8, not drawing a scale here. So that would be 8 meters. So the center of mass of the system would be located where this little x would be. Okay. All right. Other than that, here's a different way to do it. In this particular problem, the first strategy I show you would be the easiest way and I think most straightforward. However, if you wanted to, you can exercise the second strategy just to make a point. When it comes to reference point, you make a choice, and then your choice should be consistent. Okay. All right. Here, what if you were to choose M2 as your initial reference point? If that is the case, I would go ahead and put M2 at x is equal to 0. The reason you want to do that is because it eliminates one of these values here, because when you do m times x, x being 0 will just give you 0. So it actually reduces the function down to pretty basic stuff. All right. Other than that, if x here is equal to 0, well, according to this new reference point, M1 is located a distance of 10 to the left. So here I would call M1 10 meters to the left of the reference point, which is 0. If you do the same function here, you actually will get the same answer. Here, I can just go ahead and do M2 in this case. It would be 8 kilogram times 0. Once again, you want to put one of these masses on 0 just so it'll cancel out here. As you can see, 8 times 0 would just be 0. And then 2 kilogram times the new reference point would put the 2 kilogram mass here to the left of the M2, which would imply that it's negative 10. So it would be 2 times negative 10. And the sum of the masses would remain unchanged, so it would be 2 plus 8. And then other than that, 8 times 0 is just 0. And then 2 times negative 10 is negative 20. And then the denominator is still 10. Once again, kilogram cancels out. So negative 20 divided by 10 would just give you a negative 2. Now, it's important that you interpret this information correctly based on your decision making, okay? Like I said earlier, the strategy on the left would be, I think, the most straightforward one. But the second strategy here is just to show you if you wanted to, you could. And then as long as you interpret the information correctly, you should get the same value. So what I just found is referencing M2, the center of mass is located a distance or a position of negative 2 to the left of m2. So if using common sense, if this is negative 2, the rest of the distance would have to be 8 because the distance would have to add up to 10. Okay, so it would be 2 meters to the left. Therefore, it is the same location if you were to add it up. So 8 plus 2 would be 10. So therefore, the answer will be the same. And so here in this case, using common sense, you can say, well, I just found this distance to be 2. So therefore, if it references m1, so you would say it would be 8 meters to the right of m1, which would end up in this particular same position on the horizontal axis. All right. Other than that, stay nerdy. Don't be whack.